In order to understand how to harness power from the wind in a wind power situation, it's prudent to investigate the force that is available from the wind, and then take a look at how that transcribes to a torque. So let's say the wind, I'm going to represent wind coming in from this direction. And if that wind were to hit an object that is, say, a rectangular object, then it would rotate in this direction with a torque tau. When it hits that object, it would cause, there would be high pressure here, where the wind is hitting it, and this is lower pressure, a lower pressure region. And if we remember the Bernoulli effect, then we can relate this to velocity. We can relate pressure to velocity, but we'll do that below. So say this wind is coming in and it's hitting a rectangular object. That rectangular object is at angle alpha. So we'll call that angle alpha to the horizontal. If this is the horizontal, I can make an axis X and Y to the horizontal. And I can say that I can define alpha. And alpha is the angle between this rectangular object and the vector of the wind that is hitting it. And alpha is defined as the angle of attack. And that's an important parameter in wind turbine design. Now, the wind's velocity is going to hit this rectangular shape with a force. And that force is going to have two components. So there is a force in the X direction, and there is going to be a force in the Y direction. And force in the X direction is the force parallel to the wind. By definition, and it is called the drag force. And the force in the Y direction is the force perpendicular to the wind. And it is called the lift. Oops, the lift force. By definition. And similarly, if I drew this, let's say the ground here, and in a wind turbine, we don't just have a rectangular poking upwards, do you? It rotates in a full circle. So it's prudent to also look at what the angle of attack looks like if something is on its full rotation. And here, the torque would be going this way if I defined the wind coming in from the same direction. And here, the high pressure region would be near the wind, and the low pressure region would be on the opposite side of that shape. And I can again define the two components of the force that this wind is causing on this object. That's the force of drag, or I'll say force in the X direction, which equals drag force. And the force in the Y direction is called lift force. And if you can imagine this rectangular object rotating around, it's going to be in different positions, say here and here and here, then the components of lift and drag are going to be different. They're going to be a different ratio to each other. There's going to be more drag force compared to lift force, or more lift force compared to drag force, depending on the angle of attack.